Hello, and welcome to the first part of our hands-on optimization masterclass. I am Cristina Radu, and we have here Felipe Brandão from AMPL. Let's get started. We will talk today about how we are going to start building a solver. So we are going to add a few constraints. We will start with the demand constraint. And we will see the basic report you can build to validate your demand. We will add the inventory constraints, the material flow. This is the equation, which is the core of the solver. And also how would the simple report look like. And we want to introduce already the topic of infeasibility, like the type of infeasibilities you can have and how can you address them. Even if it's a very small model, we just want to introduce the concepts, and then in the next session we will have a bigger model and more causes for infeasibility. So we get to practice a bit more. And in the end, I want to give you a few design principles and ideas of how you can build diagnostic reports, because they are very useful to keep the data which is not clean out of the solver. So let's start. This is the demand balance constraint. I told you last week that we have the demand, which is an input. This is the input demand. It's a constant, and this is the driver of the solver. So everything that happens in the solver starts with demand. And this is also in this context of infeasibility, when there is something wrong with the solver, first thing you should look is demand. Because sometimes the numbers there can be negative numbers, or you can have the scaling issues that some values are very small or some values are very big. So there are a lot of issues that can happen with the demand. So this is the first tip. If you need to debug, just open the demand file and look what's happening there. And then we are defining two variables, the met demand and the unmet demand, because it can happen that not all the demand is met. And then the purpose of the solver is that we want to minimize the unmet demand. Ideally, demand should be equal to met demand, but you have capacity issues, I don't know, transportation issues, and so on. So some of your demand might be unmet. So this is a big focus of a solver when we talk about, especially when we talk about unit optimization. We want to minimize the unmet demand, so we are going to put a very big penalty on this. So the solver needs to make it as small as possible. And the dimensionality in this constraint is product location period, and this applies for each of the variables. So first for the input, so demand and product location period, and the two variables, they have the same dimensionality, but also the constraint, right? So we need to pay attention to the dimensionality of the variables and the dimensionality of the constraint. In this case, it's the same, but you can do, for example, your variables are on product location period, but your constraint is just on product period. So you aggregate by the location. So it gives you a constraint for a product in all the network, not a product location. So just this is a few comments about the demand. And at the end of the video, we are going to go in the app and we are going to practice this. So show you how to put the constraints and give you some tips about how to debug and so on. So I'm just going to go through the presentation, and then we are going to discuss practical. And this is the demand report. A very simple version is, as I said, the focus is on the unmet demand. So after I run a solver, I want to see what is the demand that is not met. And then I start to check what is the reason. And I can see that maybe I have capacity issues, or I don't know, some procurement issues or other issues. And this can justify why the demand is unmet. And then a planner starts to look around. How can I fix this? And starts to check, well, is this unmet demand from a high priority customer? If yes, well, it means they need to change the plan a bit. So maybe they move things in another bucket, or they start to move things around. So I'm also trying to explain now how a planner would look at this, right? And then they reshuffle, basically. This is let's say the manual planning part, where this is the mathematical solution of the solver, but it doesn't make sense business-wise. So they just need to move things around or increase some capacity or move some production in a later bucket such that we have capacity in this bucket and so on. So just a few examples of what you can do to remove your unmet demand or put it on another product. And the inventory constraint. I told you before that this is one of the particularities of supply chain planning, where we have buckets. And then we need to basically carry over the inventory from one bucket to another. So the ending inventory in one bucket is the starting inventory of the next bucket. So then we need to capture this in the constraints. And we have two constraints. For the first one, we say that in the first bucket, we start with the initial inventory, beginning on hand, starting inventory. It has different names, this one. And this is what basically comes from the execution system, let's say from SAP, and what's your available stock for that product. And then, as I said, for the next bucket, the starting inventory becomes the ending inventory of the previous bucket. And then this is the inventory carryover. And here the same, the dimensionality is the same for the variables. So for the starting inventory, for the ending inventory, also for the parameter, initial inventory, and also for this constraint. Because here we have just product location and period one. But here we apply the constraint for each product, each location, and each period. Okay, and now we go to this core equation where we balance demand and supply, basically. And this is the equation of how do I calculate the ending inventory, because this is the very important concept for the planner. How is the ending inventory calculated? It's the starting inventory, what I have at the beginning of the bucket, and then I subtract the met demand, not the demand, because not all the demand is met. So only the met demand, and we add production. So basically what comes in. And here we will keep adding terms like transfers in, purchases, and so on. And then with minus, we will have transfers out, shipments, and other concepts. The dimensionality, we have product location period for all the variables and for the constraint. But again, sometimes depending on what you're modeling, maybe the constraint has a different dimensionality. You say, well, I actually want to just check my ending inventory by location. So then if you leave out the product in when you define the constraint, then it sums over all the product. It does it for each location and each period, but the product's volumes are summed. So of course, this changes the results of the solver if a constraint has 3 dimensions or 2. And now we get to the report, the material report. So after you check, let's say your met unmet demand, the planners come and check here. They look immediately at the ending inventory. And the first problem is if you have a negative inventory, because it means that you are missing stock, you are missing products. So then they start to check what is the issue, why, and then as we will see in the next video, when we add capacity, they go and check the capacity. Maybe I didn't have capacity to produce, or any other reasons. But as you see here, what I said is that the inventory needs to be carried over. So the ending inventory in first bucket equals the starting inventory in the second bucket. And then from the next bucket, it's 0. And normally, if the ending inventory looks good, maybe the planner doesn't even check more. But also if it's 0 and you have a target stock, that's also not good. So first they look at if you have negative ending inventory, and then if it's 0 and you have safety stock, target stock, it means it's still an issue. So they starting from this material report, they start to dig in and find out the causes for the results that are shown. And again, they start to move things around, or maybe even change some constraints, or maybe there isn't a data issue. There are different reasons for which, let's say, the ending inventory is negative or zero. The objective function, we need to define the objective function, as our model is very simple. We have only two terms, and one is the unmet demand. So we need to put the pressure on the solver to keep the unmet demand at a minimum. And also I added a penalty for the ending inventory, because at this stage we don't have production constraints or capacity constraints or other constraints. So actually the solver produces as much as it wants, because it says, well, I met all the demand, and then I can produce anything, basically. So we need to put a penalty on the ending inventory, so then it keeps it to zero, basically. And also the objective function has a dimensionality, so we need to pay attention how to define it. And depending of the dimensionality, also results can be different. So we have a product, location, and period. And before we go to the app to talk about the practicalities, how do you write the equations and how can you debug? About the design document, because in many projects I see that it's a little bit hard to start. Like, what should we put in a design document? So the first thing you need to clarify is basically what are we actually doing, but to this very simple level. So I gave here two examples. What is the objective of the solver? What does the solver do? So we know it balances demand and supply, then across the full network. And the focus is I want to minimize the transportation cost. So this is a cost optimization. The second example, again, I balance demand and supply, but I also have lot sizes at product group level, which means that I also need to minimize the transition days between the campaigns. And this is like a different problem, right? And we need to capture all this, let's say, operational details from the beginning, because this then is how the design document gets shaped, right? So I wrote here objective and functionality. So for example, the objective is this: we minimize transportation costs, and functionality, which are very important in production planning solvers, is the slot sizes, campaign planning, capacity constraints, storage constraints, this kind of constraints, because they are technically difficult to model. So then you need to know from the beginning, because this tells you in which direction you go. And then, of course, you need to include details about the company, right? Like, yeah, scope, what locations you include, what products, what is the network, what is the granularity? Is it a product location or family product and resource, and so on. Also horizons, should we do it weekly, daily, monthly, and so on. So this kind of things, but they need to be clarified at the beginning, because if you decide to do a project of the product family, 2 months later you cannot change it, because all the modeling changes. So it's like beginning from scratch. From the beginning, you need to talk to business and ask them exactly what they want. Then data inputs. I think we discussed about this last week. The data diagnostics, which I mentioned, I'm going to talk a little bit in a minute. Objective and variable. So here you start to go a bit into the details. So what is the objective? How do we achieve it? What kind of variables do we need? What constraints? And then you start detailing the constraints and explaining what is this constraint about, what does it do, what it doesn't do, and so on. You also need validation reports. Why I call them validation reports? Because they are very simple reports, like the ones I'm showing you, to validate the results of the solver. Because business has a lot of bigger reports, let's say from SNOP, IBP, they have different kind of reports that they need to run the business. But for you to validate the solver, you need the kind of reports that I'm showing you in this course. And if you have those reports, you look at them and then you figure out if there is a problem with the solver or not. So the idea is that you don't need to have like 10, 20 lines in the report, 2, 3, and it shows you what's the problem. And then you can also have infeasibility reports or debugging tricks and so on. Because when you implement a solver and then you hand it to the business, they should be able to be independent in finding the infeasibility, in solving them, right? So then you can explain what we are going to explain in a minute. Infeasibility come from the modeling and the data. If it's data, you do this. If it's modeling, I don't know, call us and so on. So they should have a set of instructions what to do if the solver is infeasible. And the diagnostic reports, you need this to keep the bad data from the solver. Because of course, this doesn't, if you even make as many diagnostic reports as possible, this doesn't guarantee that the data is going to be good. But if you put those, then things get much easier. So you need to filter out, for example, product with demand but missing master data, because this is going to get the solver to go in loops and search and search and search and run for hours or hours. And you don't know, does it run for hours because it takes that long or because the data is wrong? So if you filter out some issues, that would be very helpful. For example, if you have this network optimization, you might have missing lanes, which is also creating an issue. Or sometimes it happens that some production orders are confirmed, especially the first packets, but when you sum them up, it's bigger than the available capacity. And the solver still takes them into account, and it will run infeasible. And you can do the same with the shipments, for example. So what if the shipment is bigger than, I don't know, the loading capacity or unloading capacity? And so on. So these are just a few ideas about this data diagnostic. I really, really recommend it because I saw many projects where solver didn't work, the customer was very unhappy. The minute we put those data diagnostic and the bad data was out, everything was fine. So, and they are so easy to set up. It just takes, I don't know, a few days maybe max, and then it's so much easier to debug, to test, to validate the results and so on. So you avoid a lot of frustration with minimal effort. Okay, so now I will let Felipe share his screen and we go to the app. So he will show you how to practice, how to write your models.
So here is the app. Just going quickly over the model and also to match what you saw in slides. So the dimensions in here are going to be these sets. The data inputs are these parameters that are then indexed over the dimensions. And here, like mentioned already last week, we are using a restrict table, but otherwise we could really be indexing over all the different sets. So demand is indexed over products, locations, and periods, but is in fact just for specific products and locations and all periods. And when defining the data, we can already introduce some rules. So this is to prevent issues with bad data. It is often good to include, in this case, it's just strictly greater or equal than 0, but you can include more complicated conditions to prevent issues with data. But I will say that is the most common thing in terms of infeasibilities and issues, especially after the application is already in production, is usually bad data, the thing that causes trouble. Modeling issues, typically you are able to catch that during the development. Then the variables also indexed over the various sets. Then let me just show the constraints. So the various constraints for demand, inventory, material balance, and the objective where we are using these penalties for unmet demand and ending inventory. So in terms of checking if your model is doing well, one of the first things is these reports. Here you can already, like Christina mentioned, check if demand is being met, 0 and met demand, so looks okay. And also the material report. So here you can see that ending inventory is moving to the following day and so on. So inventory carryover is working. So this is one way to see if everything is working well, but there might be issues. So what happens when there are issues? There are two sources for infeasibilities. So you can have issues with data. And let's imagine that we have negative demand for something. And here we are already catching this because we have this condition here. That's why this is important for you to do, so that you prevent issues that could be a lot harder to track down, because you could have just a negative demand somewhere in a constraint, and that will just be a negative coefficient somewhere that will cause weird results and hard to really look at the source. But if you define conditions in the data, you prevent this source of infeasibilities. Then another possible source is modeling issues. So you can, for instance, demand balance. Let's make some big mistakes here. Let's say that demand is plus met demand is equal to and met demand. So this one is include when you are solving the exercises. Here you have some tips about what needs to be included in the expression, and I'm including all the components just in a very wrong way. And what is going to happen in this case? In fact, in this case, it's still not infeasible, but the way to really see that something is wrong is you look at the report. And this is where you can see that there is something very wrong. So you see unmet demand with these high values, met demand 0 most of the time, so something is clearly wrong. But this could really be infeasible. Let's make it even worse. And now it is really infeasible. And here we don't even get into the solve, because before solving, Ampli runs the pre-solver and is going to identify that the body of the constraint needs to be less than or equal than -10, but the constraint needs to be greater or equal than 0. So it is clear that there is not going to be any solution. And we can see that the issue is happening in for various demand balance constraints. So you can go again, look into demand balance, and see that this is not what was in the slides. So demand is in fact met demand plus unmet demand. And the moment we do this, we are solving the problem well. And let's look at the reports. And now the reports are looking fine, just like the reports that Christina was showing. We have the demand being met every time. And we have inventory carryover happening, demand being met, production happening. So everything looks fine. So these are just simple sources of infeasibilities and issues with your model. There are more complicated issues that arise when the problems get more complex. Then there are two techniques that you can use, and typically is IIS, irreducible infeasibility sets. And there are also another that I use, which is FeasiRelax, in which you can essentially be minimizing violations of constraints. So you modify your entire problem to allow every constraint to be violated, but you introduce penalties in the objectives, and you try to minimize the number of constraints being violated. And after you run that for some time, you can look into the constraints that are still being violated, and then try to, for instance, disabling different constraints until the problem becomes feasible, so that you can narrow down the potential issues. I often go to FeasiRelax instead of IIS, especially when you are dealing with very large models. In this case, we are solving LPs, but imagine you have a MIP with like tens of millions of variables. Trying to do an IIS there can be quite heavy. So it is often necessary to look into alternatives that are going to be quicker. Another important tip here is develop your model constraint by constraint. So that, because infeasibilities, they get more complicated if you already wrote 10, 20 different constraints. And now, okay, where is the problem? When did it become infeasible? One way to then try to debug it is disabling most constraints and then start enabling one by one until it becomes infeasible. So that is also a way to narrow down potential issues. So that way you can also avoid having to go into IIS and FeasiRelax and leave that as last resource. So there are many ways to track down the issues, and then you just have to decide what to do first and what to do as last resource. And all of this also applies to different problem sizes and so on. Later, we should be able to also see some more complicated versions of this that should then require IAS. But for now,
yes, indeed. But can we show also the inventory constraint and the material balance constraint?
yeah.
Because we didn't show it.
Do you want to see the constraints or to implement?
Yeah, to show them to the people, because we should have went through them at the beginning.
Yeah, but
yeah.
the exercise,
Yeah, I just wanted to show this, but maybe we don't now, because I think we should have showed it first, like go in the app and show, let me put the hand, exercise 1, 2, 3, and then talk about the infeasibilities, but maybe they will figure it out.
yeah, because in the beginning I showed when I showed complete model.
Yeah.
I showed it like this, but I did not go
I know,
into...
but yeah, exactly. But I think it's okay because we discussed in the other videos, and I think in the other videos, I just wanted to show how you fill in the equations, a bit what you showed with the met and unmet demand. But yeah, I think it's okay. I need to check what we did in the other videos.
yeah, because I was leaving this as a homework exercise.
Yes.
But I can also solve this one and also that
I
one.
know, but leave it like that because indeed, and let's in the agenda for the next session is homework. So then we will show it there, basically. So if they are curious, I'm going to say it like now. So you have the homework to write the 3 equations, and next time we will check it together. So yeah, maybe let's do that, right?
Yeah, because in here I showed the demand balance. Now I stop sharing, and when you do the next part, you start by mentioning, okay, inventory carryover and
yeah. So yeah, let me the
we're not
agenda
shown
again.
because they are exercises.
Yeah, okay. So let me just wrap up the session basically. So, okay, ready? Okay. So what are we going to do in the next class? So you have homework to write in the app the demand constraint, the inventory constraint, and the material balance constraint. And next time we are going to write them together in the app so you can check if what you did is correct. But you also saw the solutions today. They were shown by Felipe when he was scrolling up and down. So the equations are there. And you can also download the model and check there, of course. But yeah, try to do them yourself. And next time we are going to add more constraints. So we are going to talk about the production hour capacity. Also, we are going to add transfers. So transfers are the stock movements, which are like intercompany movements. They are also called STRs, STOs. So this is the type of movement. And we will practice how to transform a hard constraint into a soft constraint. We are going to do that with capacity, because in some models, capacity is a hard constraint. You are not allowed to go over. And in some other models, it's more relaxed. So then you model it as a soft constraint and add a penalty. What happens if you go over? And we are going to practice more infeasibilities. Today, as you saw, the model is still quite at the beginning, so there are not so many reasons of infeasibility unless you write the model wrong. And then we keep adding data and constraints, and infeasibilities could appear. And we will discuss a little bit about those restrict tables, which are also a debugging tool. Because by restricting the number of combinations you put in a solver, of course, you reduce the probability that something goes wrong. this is it for today. Thank you very much for watching, and we'll see you in the next class. Bye.
Thank
Thank you.